Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. Welcome back. So we proceed with another section, which is how to convert between state space representation to transfer function. Okay, um, we have to consider the state equation. Okay, that we have I have shown to you just now. Okay, and the output equation. So equation 215 and 214 and equation 215. Okay, which is the one that we have just now. Okay, so question state equation we have again, like we have a okay, x plus b, okay, u. Okay, this is state equation, and then we also have output. Okay, so output is y equal to c x plus b u. Okay, so this transfer function we can obtain by taking Laplace transform. Okay, again by having the assumption initial condition are all zero. Okay, with some algebraic operation. So you can follow the following step. Okay, and these are the step taking Laplace. Okay, can write in this form sxs axs plus bus, and then ys is c xs plus bus. So this equation we can write by taking Laplace for both equations. Okay, so this is equation 290. So we can express a state equation in terms of output equation. Okay, so we have x as this one we want to express in terms of output. So jadikan xs as the main, and then you solve s minus inverse a, okay, inverse a s minus a to the power minus 1, and then b times us. Okay, so in this case, what is s minus a inverse? S minus a, what is s minus a? It is known as transition metric. Okay, transition metric. And then you substitute equation 20 to equation 219. Okay, equation 220 you substitute into this equation, so you're going to get ys. Okay, so this xs you substitute, you get from here xs, you get from here. So what you're going to get, you're going to get cs minus times s minus a to the power minus 1 bus plus bus. Okay, simple substitution. All right, and then now the transfer function is obtained by taking ys upon us. Okay, transfer function one way we defined earlier. So it's going to be ys is this one, because we want to write in term of transition metric. Transition metric. S minus a is transition metric. Yeah, so it becomes c phi to the power of minus 1 b plus d us, and then taking the ratio of it, you're going to get in this form. See, in parentheses, this is phi, okay, to the power of minus 1, okay, times b plus d. Okay, this is the transfer function. Okay. Okay, in order to make it clearer, we do this example. Have this example, work example, uh, mechanical system, in which state space representation, okay, is given in equation 214 and 215. So equation 214 to 15, remember, equation 214 to 15 is this one. Okay, we have state equation and output, and then with matrices A, B, C, and D. Maklumat semua dia dah bagi ni here. With matrices A, B, C, and D. So A is minus 2, 1, 0, K1. B is 0, 1, 0. C is 1, 1. D is 0. So find transfer function of the system. Okay. So you can try to do it. Okay. I'll give you 4 minutes. Try to figure out how to find the transfer function of this system. Okay. This is a state equation. This is the output. Okay, so this is 14 and 215. Okay. All right. So all of the information is given. So you need to determine transfer function of the system. Okay. From question 2.22, we have this equation. Okay, which is C phi to the power of minus 1 times B plus D. Okay, so what we need to solve is first of all, we need to solve the transition matrix. Okay, transition matrix. So phi equal to S minus A. Okay, transition matrix. So S 0, 0 S minus 2, 0 K1. Okay, which is this one. So it's going to be S plus 2 0 minus k, and then s minus 1. Okay, this is number 1. Next one is need to find the inversion of the transition matrix. Okay, find the inverse of it. Okay, the inverse of this, which is 1 over this matrix. So S1 plus S2. Okay, S1, the inverse. It's fine, need to recall how to do the inversion. The inversion of the matrix. Okay, and then you're going to get there in this form. Okay, and then you proceed with the transfer function. Okay, transfer function ys divided by us. Okay, based on this substitution. Okay, so you get 1 1 1 1. Okay, all of the information is given here. So 1 1, you substitute C and D here. Okay, all right. So we have 1 1. Okay, and then transition matrix. Okay, p to the power of minus 1. Okay, and then what else? 1 0, which is B. Okay, and then D is equal to 0. Okay, this is the one that we have obtained. Okay, ys over us. Okay, and then you do the simplification. Okay, of all of this until you obtain this value. Okay, in this form. Okay, a plus s minus 1 divided by s2 times s minus 1. Okay, for example 1. Next one, 2.24 is the conversion between transfer function to state representation. Okay. Okay, this is how we can convert the one that we obtain, transfer function to state space. So we have this equation. Okay, consider this one. We have in this form 24 divided by s cubed plus 9 s squared plus 26 s plus 24. Okay, so first thing we need to convert this equation into ODE, ordinary differential equation. Okay, so you multiply both, cross multiply. So we're going to get 24 US and then YS multiplied by this value. Okay, and then you take inverse Laplace transform. Okay, so s cubed is going to be in this form. Okay, in this form, d cubed y and then 9 d squared y, 26 dy dt plus 24y. Okay, and then this one you're going to get y triple dot plus 9y dot plus 26 y plus 24y equal to 24u. Okay, and then next one we define state parameter. Okay, state parameter you're going to get we find z1 z2 and z3 with y dot and y double dot. Okay, and then you do the derivation, rearrange expression according to state and output equation. Okay, so this is state equation and this is output equation, the one that we have done twice just now. Okay, and then you're going to get the output as the following. Okay, system output you're going to get as the following. This is state equation. Okay, then this is the system output. Okay, system output. So equation 229, 230. Meaning you can do back and forth. Okay, back and forth. Once you obtain this, you can do a reverse order, reverse way, reverse way. To convert between transfer function to state space representation, you can, of course, can do it. Okay, by using the step that I have mentioned. Okay, this is another one, 231. Okay, work example 231, process, transfer function process, which is this one. Okay, so we want to find its state space representation. Okay, so we can have like this. First step, we want to separate upper and lower polynomial into cascaded form. Okay, so can have y output divided by input, so it's going to be as the following. Okay, which is s, we cascade into 2 s square. This is numerator and this is denominator. S cube and s cube, and then we convert transfer function into ordinary form. Okay, ordinary differential equation form, taking inverse Laplace with initial condition of 0. So we're going to get d cube x1, so 9d square x1 dt, and then 26 and 24. Okay, and then for yt is going to have d square x dt square 7 and then 2x. Okay, 2x1. Okay, then we proceed like before to define state parameter. Okay, and then rearrange into the state equation. Okay, in this form, and then for the output, okay. But the only thing, from cascaded form, we obtain the output as the following. Okay, which is s square plus 7s plus 2, which is this one. We have cascaded plus 7s plus 2. Okay, so the time domain from we can obtain from equation 2.33, but the state variable is defined as the following. Okay, so just now we have obtained 2.33. 2.33 is this as the following, and then we need to define the output to be in this form. Okay, state variable z1 x1 z2 x dot 1 and z3 x double dot 1. Okay, so system output simply in this form, b2z, b1 z2 and b dot z1. Okay, so it's going to be as in this form, 271 z1 z2 z3. Okay, this is the system output to match with the cascade one, 271 z1 z2 z3. Okay, so we have, okay, this one 271 z2 z1 271. This is 271. Yeah, 271 271. Yeah, 271 271. Okay, any question? Did I give you the tutorial question for the topic for you to do? You have, right? I think I have given you. Hello. Anybody respond, please? Did you have did I give you the example, the tutorial?
Untuk chapter ni betul.
Yeah, for this chapter. Not yet, eh?
Belum lagi rasanya.
I think I've given. Let me check. Okay, because we learn by doing. Okay, when you do, we will understand. Team teaching. Let me see. So far, I have given you assignment 2, right? Assignment 1. Okay, let me see. Assignment 1. Okay, how to find Laplace apa semua tu. Okay dah. Solve ordinary. Okay, this one I will find. Okay. Assignment 2. Yeah, assignment 2. Assignment 2 is the one that our lectures today. Okay. Okay. So in our next class, we are going to look into detail on how to do block diagram manipulation. Okay, block diagram manipulation. Okay, it's going to be step by step. There are simple rules for block diagram algebra. Okay, Amala how to add the one in series, in parallel, like you learn in electrical circuit. Okay, you remember important rule for block diagram reduction. Okay, so we're going to do it in our next class. Okay, I think that's all for today. Okay, selamat buka. Okay, so hopefully you can do the tutorial. Okay, so when the tutorial due?